Good morning, good afternoon, and good evening to everybody, and welcome to another session of Expand Your Horizon. Excited to be with you all in the first session of 2025, and also excited to have Anna with us, Anna Cheniuntai. How are you, Anna?
I'm doing great. Thank you so much for having me today. Really excited.
Yeah, thank you very much for joining. Sorry for the early hour. I know it's 8 o'clock your time in the West Coast, so really appreciate the fact that you're joining us. We're going to talk today about construction and robots and 3D building and 3D printing of houses. Very exciting. But maybe before we kick it off, maybe you'll tell us a little bit about Anna before UpScore.
Yeah, absolutely. So my journey started pretty early. Uh, my parents, my mom, and my grandmother, they were also entrepreneurs, and that they were doing Airbnb like years before Airbnb actually was, invented. And I was all the time so inspired how, they just really control their life. They hard work, they work hard, but also party hard, and just all the time help them in everything. And I was like, whenever I'm gonna be like them. I'm gonna be entrepreneur. And I didn't know like exactly what I'm going to do, but at the same time, in the high school, I saw how everything is really bad happening with our planet, especially oceans and wild nature and animals and like our climate and everything and environment. I was like, oh my God, we're all screwed. What are you going to do as an entrepreneur? It just like, are we going to exist in like a 10, 20 years? It was really like a dark time for me. I was just really thinking about everything. And then I was like, whatever I'm going to do, I'm going to be part of something big and really impactful. I don't want to do like standard things like entrepreneurships and like running the business and then sell it. It has to be big and it has to be in fact impactful for the planet and change the world. And with this idea, I was like, okay, now I need to go to university. What am I going to study? And with this idea, okay, I don't know what I'm going to do as an entrepreneur. So next 5 years, I'm going to spend my time to study something really interesting. And then I will figure out what is going to be that big, impactful thing I'm going to be part about. And my parents and my grandparents, my entire family, they come all from science. So they are masters or bachelors and PhDs in mathematics, physics, and geology. So I was like, okay, I'm going to go and study physics. It's going to be very interesting. I need to know how the world works while I figure out what is going to be like my journey as an entrepreneur changing the world. And I studied space physics for 5 years. That was an incredible journey. And on the last year of my university, I met Nick, currently my co-founder and also husband. We are a married couple and we are running Episcore. But even before starting Episcore, me and Nick, we were doing construction projects. We also were doing the company that building the industrial machinery and robots. And Nick, he comes with all of this experience in robotics and entrepreneurship and business. And I was like, oh my God, you're so smart and you're doing such a crazy things. I just want to stick with you and I want to be helpful. I want to learn and want to be part of this. And this is how I learned a lot about robots, industrial machinery and construction. And then we've got a very big construction project on Olympic Games. It was in 2014, and we were responsible for millions of people not to get lost on Olympics, meaning that we had to produce and deploy 5,000 navigation signages that would show people all of the directions, like where is the bank, where is the stadium, where is the train station, and we were like 20.
The London Olympics?
No, that was in Russia, in Sochi. I was born in Siberia, so we also come from Siberia. And so we were like a 22, 23 years old, and we were responsible for such a pretty significant activity at the Olympic Games. It basically was face of Olympic Games. And when the Olympic Committee, they saw us, they're like, oh my God, we're all going to be fired because these kids are not going to deliver and we're all going to be in troubles. However, we delivered this massive project ahead of time. And even later, they asked us to pick up the project that another big company was doing, but they were failing. And we basically cleared the problem that that company created. And so this is how we made our first big money together. And then we're like, okay, what's going to be the next big thing, right? With this experience, with these opportunities. And Nick, my co-founder, he basically came up with the idea of the 3D printing robots that we use today. And this is true novelty. It's never existed before. And he just basically reasoning from the experience in construction and robotics. And he was like, robotics and automation have to be presented in construction industry because we saw how outdated it was. It's all the time rely on the skill labor, which is really hard to find, very expensive. And so this is how Episcore started. And the idea originated in 2015. So since then, I've been fully with the company, really enjoyed the ride, and really happy and excited about what we are doing. And yeah, that's basically the story behind Episcore about me. And I also actually wanted to be a teacher. I wanted to teach physics and math. And even me and my friend from school, we started like a very small private school where we were teaching privately mathematics and physics to help kids to pass exams at school. But that was quite a short journey. Then Episcore happened, and I was like, I'm off for another story.
Yeah.
Yeah.
Yeah, founding a startup is more than a full-time job.
Yeah, exactly.
And at which point did you move from Russia to a different country? When was that? With Episcore or before that?
Yeah, it was with Episcore, and I think it was like a very early 2018. Yes. But even before, we already was pretty active here, like, establishing the relationships and really seeing what this country is about. And we were so excited and like really so inspired. And we knew that if we really want to build something big, especially with the technology that we were building, the United States, America, and Silicon Valley, it's like really the number one place where we should be if we really want to make this successful and big.
Yeah. And I'm guessing you don't have a lot of free time being the co-founding member of a startup company, but when you're not working, what do you like to do?
So yeah, I managed to actually figure out my free time because I don't have like a hobby or something. I still trying to figure out how to make time for like going to gym or running or something like that. And I figured that I also passionate about the education and helping others. So I'm doing a lot of like a non-commercial side projects, more like a non-profit. One of them, it's my little initiative, as I called it. I started procuring laptops and used laptops and send them in kids in Africa and also in war zones. And I was able to procure almost 100 laptops since 2022. And that was quite a journey, and I'm trying to make it bigger. And like my friends, they all the time helping me with this, with packaging the laptops. And one of our investor and partner, D.R. Horton, the largest home builder in the United States, they also were playing really a big role in that. They just donated 50 laptops to me, and this is how my initiative really like streamlined. So I'm still doing this. And another project is also Female Founders Edge. Me and my friend, we met here in Silicon Valley. We both alumni of Alchemist Accelerator here. And we basically started this nonprofit to promote female founders and give them the voice and exposure and connect them with the mentors and all of the resources. And I'm working on my next panel that I'm going to be hosting in early March. So this is very exciting. Yeah. So this is my free time,
Amazing. So but maybe last question before we move into Episcore and construction and 3D printing, something that we ask all our guests. What are the two things that Google doesn't know about you? Or maybe today we don't need to say Google, we need to say Perplexity, ChatGPT. But same question. What Google doesn't know about you?
So I think one that I'm a parent of a lovely 70-pound pit bull.
Right.
He's a really lovely dog, and I really like pit bulls. It's my second dog. And second one, I think that maybe, yeah, that I wanted to be a teacher when I was a child. That's something, yeah, it's actually never been shared before, but yeah.
Thank you for sharing all of that. And maybe let's switch gear and review the main part of today's session. And let's talk about how you're revolutionizing the construction industry.
Yes, absolutely. So yeah, I'm here today to tell more about what Episcore is building and what we're actually doing. So Episcore is the company that built robots to 3D print full-scale concrete houses. And here you see the robot. It's one of the early prototypes that we have, and this is the building that we 3D printed using this one single robot. And this building is still officially Guinness World Record as the largest home builder, Guinness World Record as the largest building 3D printed on Earth. And just to be clear, we 3D print the walls only. And then the windows, the roof, and all of the furniture is done traditionally, but the structure of houses that's built robotically.
And this is where? In Florida?
No, that was in Dubai. That was one of our early prototypes, and we just had we just assembled first printer, and then Dubai municipality said, like, we're really impressed with your technology. How about you come and 3D print the biggest building on Earth? And we're like, yes, challenge accepted. And we did that. So yeah, that was in Dubai.
Nice.
Yeah. And so, but basically, like, the idea why we need this and why we really need to introduce robots and automation into the construction is that realistically, our population on Earth is growing rapidly, but still, like, we're so behind in terms of how many houses we're able to build to support every single person on Earth with a decent housing. And it's like McKinsey calculated is that by to meet the demand, we will need to build as many houses as we built for the previous 2,000 years. And it's like a pretty aggressive, considering that the biggest home builder in the United States only built 1 million homes for the past 45 years. And like, how are we going to achieve such a big demand? And obviously, there are other problems that impact, such as slow growth of the building more houses. It's skilled labor. This is the first one, especially in the United States. It's getting more harder to find. It's getting more expensive, and the reason for that is that the workforce is getting retired, and the new generation, they just really have a zero interest in doing hard physical work outside in the harsh climate conditions, like mixing the concrete and putting the layers like bricks together. So where are we going to have all of this labor to do that? That's going to be a pretty significant problem in foreseeable future. And then now you see all of these disasters, like a climate disaster that happens in Florida. We have like a hurricane seasons, and now it's time between every hurricane is getting shorter and shorter. So you even like have less time to rebuild your house, and that also bring all of the problems with insurance, especially right now, as you know, about the devastating fires in LA, and also in Florida after hurricanes. Insurance companies, they just don't insure your house, or it's like a 300 like a 3 times higher than before. People used to pay like a $3,000 to insure the house a year. Now it's like a $13,000 or $15,000. So it's getting more and more complex, not just even to build a house, but how to own it and how to get the house survive all of this climate changes and disasters. And of course, like waste and how really not really productive the construction process right now. The way we build, it's basically we using the square materials like bricks or wood sticks, and you all the time need to cut them to create the shape that you need. It's all of the leftovers, all of the packaging, a lot of packaging. And then like you have about 8,000 pounds of waste after you build this just single family house, like a standard 200 square meters, for example. So all of this making even like a very hard to change the situation in such a conservative industry like construction. So we decided. Yeah.
Sorry, finish the video and then I'll ask a question.
Yeah, so and we decided to address this problem, this big challenge with the robotic system and basically 3D printing technology, how we can create the structures of the houses pretty quickly with the less labor required, and also be more sustainable, responsible. So here you see Frank and Gary. We name all of the robots we have. Frank is the 3D printer, and Gary is the mixer, all proprietary. And they come to the site, they 3D print the walls. We also have Mary. This is the bulk truck you see right now. Mary delivers the concrete to the site. We also have a special blend of concrete. It's basically right now cement, sand, and some additives, but this mixture is pretty available. There is nothing like so unique or like a hard to source. Here you see how Frank is printing the walls. And Frank is very compact. One operator, he can just, use the joystick and get the printer back to the trailer. And this is how you can bring the Frank and Gary to another construction site. And then once the 3D printed walls are done, you reinforce them, you insulate the walls, and basically you continue finishing the house as you would continue the traditional house. Here you see the final product. It's our recently built home in Melbourne, Florida. This is where our company is located. And you can see all of the different details that we were able to print using our technology. It's a 4-bedroom, 4-bathroom house, and it's going to be on the Airbnb or like available for short-term lease pretty soon. And again, like in these houses, we 3D print directly on site. We don't 3D print the walls somewhere in the factory and then bring them to the site. Frank, our technology, able to 3D print houses and structures of any sizes, meaning that it's like a tiny home, 100 square, like a 10 square feet, or it's like thousands of square feet buildings, like malls or storages or whenever you want. As long as it's up to 2-3 floors, Frank can do this. Yeah. And you had some question, right?
Yeah, I had a question on why many of the houses in the US, at least, you mentioned Florida, and I know, for example, LA and some other regions, they build mainly with wood.
Yep.
And at least some of the countries that I'm aware of, even small private houses are built with concrete or with brick. Why in the US wood is the preferred material?
That's all about the costs. Historically, labor was, you just need less labor to build the structure quickly with wood. And that was basically the driving factor for that. But then you see that lumber cost was just skyrocketing after COVID. And labor right now is still like already getting hard even for the wood framed houses. And so now everybody is thinking like how to transition to more resilient homes in construction using concrete, especially after fires in Los Angeles. But the main reason was just availability of labor, because you can build up the structure pretty quickly. So your costs for labor are not that big, because you don't need labor for a long time. Yeah.
Yeah. And even when you switch to concrete, you're using your technology, is the cost competitive with a wooden type of house?
Currently, yes. Because it's of course like very depend on the location. Some of the states and locations are more affordable for wood framed houses. It really depends. Construction is so fragmented, especially here in the United States, and costs are so different and depends on many factors. But where we really save money, it's on the structure of the houses. And also we work with the home builders. So our goal is to provide our technology to the home builders who already built, let's say, like hundreds of homes a year, and they really want to expand and deliver more, but they're not able to do this because they're very limited in the skill labor. So for them, it's like, okay, how to build thousands homes instead of 100 homes as we build right now. And robotics and the scalability that technology provides, that's the solution for them. So if you look at from the developer side or like a construction company side, they're not really thinking about one house, but how they can actually increase ROI on their projects by delivering faster and selling more houses sooner. Yeah.
Yeah. Understood. And if I understood correctly from the video, so you assume that there is a foundation, so somebody like a regular laborer or a construction company would prepare the foundation, and then
Yes.
and then you build all the rest, other than the house, other than the roof and the internals, right?
Yes. So basically, how it works. Especially here in the United States. So first you buy the land, you design the house in the same way as you would design it for the traditional brick house. So nothing really different here. You design all of the engineering specs, how the house is reinforced, insulated, how the roof is attached. So we follow all of the existing building codes. There is nothing really specific here how to design the house. And then once you have your construction documents and design approved by the building officials and building department, then you go and start construction again in the same way as you would start it with a traditional type of building. So first you build the foundation, concrete slab, as we call it here. And that's pretty quick and easy process to do the concrete slab. And we don't see the benefit of using 3D printer for that because it's still faster just to pour solid, a lot of amount of concrete, and then it's done like in a couple of days. And once the concrete slab is ready, you wait maybe like 3 days. So it's get all of the strength, and then you roll out the 3D printer and you start printing the walls. At the same time, you do the reinforcement, insulation, so that it does exist. Our walls are not empty inside because this process is not that clear, but we do reinforce the walls. And then you proceed with all of the rest of the parts like a roof, windows, mechanical, electrical, plumbing, everything like that. And then you get your house done.
Yeah, and just to get the feel for what's the speed? Maybe there's a certain speed that you can do today, and maybe something that you plan to achieve maybe 2-3 years down the road. But a house like this that we see in Florida, how long it took to Frank to build this house without the roof and the internals, just the external?
Yeah, great question. So for the walls here, and it's pretty big house, it's 2,400 square feet or 240 square meters house. And it's also like a lot of interior walls. So printing time, just the printing time, it was 7 or 8 days. But that was spread within like 1 month because we were doing some of the testing and like a G-code and like a learning and everything like that. So currently the speed is 1 week per, structure of a house. And in the United States, it can take like, weeks to do the same using labor, because also Frank is available every day, never cancel the job. You schedule it, it comes and it works. With the people, unfortunately, you can schedule 10-15 people on site, they come, but next day nobody shows, and you're like, oh, what's going on? And you're trying to find another subcontractor, and another subcontractor saying like, yes, I can provide you the crew today, but it's going to be like the rate like a higher 2 times, right? Because all of this stuff happens. So yeah, this predictability and consistency is a big factor for the construction.
I think it's probably one of the most frustrating life events for people to build a house, especially because of all the things that you mentioned. You set up appointments and people don't show up, and then when things go wrong, and it's just very, very frustrating. I remember when my parents built their house, my mother almost lost her sanity because of that.
And then it starts designing the house. Once it's built, then everybody decide how it's going to look inside. It's another stage of insanity to agree on the design, you know. But yeah, and for the goal and like going forward, we actually want to achieve that we 3D print the shell of a house per day. You know, it's like not 7 days.
1 day.
Yeah, it's going to be 1 day, and we're going to use 2-3 printers on site, because as you noticed, the printer, the technology that we have is pretty modular. So we move the printer around the slab to complete the house. This building, this house that you see, it was 5 printing positions, meaning that we moved the printer 5 times to cover the printing area. And imagine that we can actually have 2-3 printers in the same slab, synchronized and working together. We can significantly speed up the printing process, but also our technology, the robot itself, the software, material science, we constantly improving that, so we can actually increase significantly the printing speed of each robot. So the goal is like 1 house a day, basically, in the future.
Amazing.
Yeah, and this is more pictures of the houses we did before. Actually, let me come here a little bit. So we started with this big building that was still Guinness World Record as the largest building on Earth. It was 640 square meters of living space, and it was a 2-story building, which is about 31 feet, which is about 15 meters tall. So it's like a 2-story building, but it actually looks like 4-story building. And the amount of material that we extruded, you know, to 3D print the walls would be enough to 3D print like 12 houses like this. So it was one project, but it was so important for us to learn the technology and make it better. And at the same time, we were participating in a NASA competition, and we took all of the first level places where we participated in all of the levels. That was more about the someday autonomous construction robotics 3D printing technology can be used to build shelters for first to arrive on Moon and Mars, because obviously if robots are going to be the first who are going to be sent there to build the structure and infrastructure first, and then people would come. And the challenge was that you can't really touch the process, and even remote communication with the machine would significantly drop the score, because it's 20 minutes delay in communication between Earth and Mars. So if something goes wrong, you would rather, you're going to have a pretty big delay to fix it. So ideally, everything should be autonomous. And yeah, we were very proud of this, that we just pushed the button, and then we had 5 hours of printing with like very little interventions. And then we also 3D printed the commercial building for the company, the leading company in aerospace. That was 2 years ago, 2021. 3 years ago. So, and then we also completed this house in Florida. And as we speak, we actually print 2 more houses in Florida for Habitat for Humanity. And now we're preparing for the next projects with the D.R. Horton and other home builders. So we're right now basically in very exciting phase of expanding and entering the market and building more printers, because right now the technology is quite de-risked, because we spent 6 years to figure this out, how to actually make it work. So now we're really happy to start building more printers and put it in the hands of home builders.
Yeah. Can you share? I don't know if it's available, but what's the cost of producing Frank? I guess Frank is more complicated than the mixer, but what's the cost of building it now, and maybe what the cost when you start really building at scale? You know, tens or dozens or hundreds of robots per year.
So we sell the printers right now as a price of $650,000. That includes the printer and Gary. Right, it's like a duo that only works together. And yeah, Frank is more mechanically sophisticated, but mixer, Gary, it's kind of like the brain of the entire process. It's a lot of electronic parts there. So it's like a big computer as well this computer on the back of the Gary actually orchestrate all of the movements of the printer and Gary and Mary and the entire process. So currently, yes, when we just expanded the first stage of the manufacturing, so the cost is going to be a little bit higher than on the large scale of manufacturing, because currently we produce the first commercial version of the printer is like a design freeze right now, so we're not expecting to like significantly keep changing the technology. And of course, in like 1-2 years, when we go to scale of like hundreds of printers built every year, the cost, of course, is going to be significantly less. And our idea is like how to make this technology as available as possible, meaning so we can reduce the costs and every single home builder across the world can afford it, and then put it in the for the good cause, how to print and build more homes. Yeah.
Amazing. And I'm assuming that all these houses that you build in the US, they comply with all the housing regulation in terms of safety and fire avoidance and all of that, right?
Yes, correct. Great question. So basically, this building also comply with the building codes in Dubai. So it's also fully reinforced. We did a lot of structural calculations before we start printing this building, because that was quite significant and serious building. It's actually very, very strong because we put a lot of safety factors there. We were doing this first time. It's a lot of rebar inside. And it's really like the building can be as a bunker, if something bad really happens. But here in the United States, let me put this way. So basically, the way we build homes right now, or walls, how we 3D print the walls, we fully mimic the concrete block construction. Concrete block construction is like a big gray blocks. And that means that we don't really try to introduce something new. We're saying that you look at the concrete block walls and you look at our walls, they basically identical. Let me show you something. Here. So they basically identical. When you build the concrete block walls, you reinforce every other, cavity of the block inside. We do the same. And our material is actually even stronger than the concrete blocks. Concrete blocks, it's about minimum requirements is 2,000 PSI. Our material is like from 3,500 PSI to 5,000 PSI. So it's way stronger. And this is how it's also very attractive for people in terms of like how the house can be stronger when hurricanes happens and everything like that. And fire resistance is better, of course. And we also insulate the walls inside. So here you see this is the reinforcement, right? And then the any other cavity also insulated with the foam or any other material that you want to insulate your house. So yes, they fully comply with the building codes. And we expect them, and we're very sure that it's going to be even more energy efficient houses, because we don't have all of this cold joints, right? When you have the bricks glued together with mortar, it's all of the points where the heat can basically leak from the house. So the walls that we print is more solid and more like a contained inside. Yeah.
Amazing.
Yeah, and this is another way how to insulate the walls as well. For really like cold weathers, for example, instead of injecting the insulation in every other cavity, we can actually build another cavity and put as much insulation as we want. And this is actually that makes the technology so amazing in terms of how to achieve higher R value. R value is basically how good your house in terms of like not to get too cold very quickly or too hot inside very quickly as well. So for the printer, you can see that we can 3D print walls of any thickness So for us, it doesn't matter if we print like an 8-inch wall or like a 12-inch wall, but thicker the wall, the higher R value you can achieve. And it does not really change any costs or timeline, a little bit longer to print, but that would be very hard to achieve the same with the traditional materials. It would be at least very expensive. So you see how flexible the technology is.
Yeah. And maybe a stupid question, but I see that the wall is very thick. What happens if you need to put a door or a window? How do you make it happen?
Yeah. So this is quite unique. This is actually the concept. We never 3D printed this wall. It's more like to demonstrate that if you really want to build something, like a bunker or like a really very good, well insulated house, you can do this. But currently, what we do, we build a wall like this. And this is 8-inch wall. So it's the same as like the concrete block wall right now. Let me show you this. So the walls are actually, here, for example, this is the building in Dubai. This, I believe, maybe like a 10-inch wall thick. And you see how much reinforcement we put everywhere. So the walls they can be as thick as you want, and as long as your engineer is happy about that. And then you install the walls, the doors and windows like this. So we just don't print here. So the printer, he knows where the wall continues and when to stop, because it's going to be the door installed. And so that's not a big problem, actually. Yeah, and here you see the printer printing here, and it's how big the building was.
Yeah, I wonder from a cost point of view, okay, how much if you had to build this thing not with a robot but with labor, what would be the ratio between the cost of the concrete and the cost of the labor? Like, is it like completely off balance?
Great question, actually. So labor is the bigger factor here. So materials, if you build at scale, this is very important. If you're a pretty big developer and you build at scale like 200 homes, 500 homes a year, you of course have a better price for the materials, crew and people all the time available for you because everybody want to work with you. And also what is really important is that you can schedule out all of the activities to complete the house very efficiently. So for the big home builders, they're very good at scheduling. Once the concrete slab is ready, walls is ready, and then the next day the crew comes with windows, next day roof and everything, inspection, everything like this. So for them, it's more about costs may be the same. And they say even if we save 5%, but we can significantly scale up the process, it's already a big win for them. Because remember, big home builders, they just really need to build more homes and they need tool for that. But if you're a smaller builder, you don't have this luxury that you come to the subcontractor and say I'm going to have 100 projects for you to build. Let's say you only 10, 15 or 20 per year. This is where all of the problem starts, and you can't really schedule this like a roof after the walls and everything like that. For the smaller home builders, it's like a 50% cost savings on the walls. Just on the walls you can achieve, yes. And with the more large scale home builders, it's a little bit less, but it really depends where you build, what the design, and kind of a different value proposition, but the ultimate goal is how to build more houses, how to help home builders to build more houses more efficiently, environmentally responsibly, and of course save costs. Because also another very interesting factor is that this is the quality of walls that we print. Just a second. Where is this? Yeah, so this is also that makes us very different in the market. This is the quality of walls, how we print. You see the surface is pretty smooth. You just see the strips that it's printed. Other companies, they print really sausages, as I call them. So it's people don't really attract to live in the houses like that. Plus, it's a very big dust collectors. So you need to apply a lot of stucco just to make this wall smooth. we don't need to apply this stucco. And it's something that also home builders can save a lot. They say like, oh, your walls, we can just paint them. And sometimes you can save like a $7 to $10 or even more $1,000 per house just for the exterior stucco. And stucco also the problem here, because if it's not installed, yeah, it's labor. And if it's not installed properly, then in 2-3 years, it's all cracked and you need to rebuild it and change it, like fix it. And sometimes it's like $100 million lawsuits. Depending on how big the neighborhood you need to fix. So this is another item in your construction costs when you also can save money.
Impressive.
So how much time do we have more? Because I can stop and we can answer questions, or I can continue. Let me know.
Well, you can take a few more minutes, because I was already asking questions in between, and I hope I answered already some of the questions. So feel free to take another 5-7 minutes to complete the presentation, and then we'll take more questions.
Okay, yeah, and so I really wanted to address the environmental roadmap and like environmental impact that we do with this technology. So first of all, it's the materials. So currently we use the concrete, special blend of traditional concrete, as I call it. Cement, sand, and some additives, which really like a 10% of the material that makes the material extrudable, like able to stack layers. If you use regular concrete, it's just a puddle. You can't really form these layers on top of each other without any stops. So this is where the material science come in, and we can create the concrete that actually extruded like this, not like a puddle when you build the concrete slab. But at the same time, even currently, we use 12% less cement in our formula compared to the concrete blocks. So even today, we already make this impact how to reduce usage of cement, because as you know, cement industry, production of cement, it's one of the highest polluting industry in the world. So everybody is trying like, okay, how we can switch the gears and like instead of cement, create something more eco-friendly. And in the future, we know that this technology actually opens the horizons to introduce new materials. And so we are working on that in the future, we can switch to cement-free materials like geopolymer, for example. Geopolymer, it's not plastic. It's actually concrete, but without cement. It's a different type of binder there. And geopolymer is way more fire resistant, is way more water resistant as well. So imagine like millions of homes going to be printed without using cement. And our technology actually allows to build millions of homes faster. So at scale, using right material, we can make a huge impact. And also working with another companies who even today already have the solution for the carbon negative concretes and cements. So we're going to use with them as well to partner up with as many companies as possible who may create the material for us with the low cement content. And another thing is also the transportation emissions. So as you already saw, we use Mary. It's basically bulk truck or like a trailer, big barrel on wheels that deliver the dry material to the site. And it's important to also understand the process is that this concrete, it comes to the site as a dry powder, fully blend already. And then we basically just connect the hoses between Mary, Frank, and Gary. And Mary starts sending dry material into Gary, the mixer. Gary mix the dry material, dry concrete, with the exact amount of water that needs for this particular formula, fully automatically, and then immediately send it to Frank to 3D print it. And so basically per house, we just need one Mary, and that will be enough to 3D print the walls for the single family house. Compared to the traditional concrete block construction, you would need to have like a 3-4 semi trucks just to deliver the concrete blocks. Yeah. So it's one trip versus like a 3-4 trips. So we already saved 3 times just for the gas emissions for that. And another factor is construction waste.
I think correct me if I'm wrong, but when you already come with the, how do you call it, the ready-made, the ready-mix blend, concrete.
Yeah,
you need the engine of the truck to stay continuously working, otherwise it will dry up.
Yep.
Here, the moment you brought Mary, in theory, you can take the container, put it on the construction, and that's it. You can the truck can do something else.
Exactly. Yeah, I didn't want to explain that because sometimes it's like too many details, but you're so brilliant. Thank you so much. So if you look at this picture, this is the actual, the barrel that contains the dry material, and this is the semi-truck. So semi-truck doesn't need to stay at the site during the printing. It basically drops off this big barrel, then it can leave to the another site. And once this barrel basically empty, this trailer or like a truck comes, pick up the Mary, fill it up again with the material. So yes, this is absolutely right. And also we use batteries to supply the electricity and power for the entire process. We don't need to have currently the diesel generator or another generator. It's actually like all electric. We built the first battery just buying a Tesla batteries on eBay, and we built together the special battery for us. So yeah, this is another thing that's perfect. Yeah.
So sorry for the very, very geeky question, but it just relates to something else that we're working on. How do you transfer the dry material from Mary to Gary? Is it gravity only, or you use some vacuum? Because dry material is more difficult to move from one place to the other.
Yeah, we use pneumatic system, and it's basically like the pneumatically sent there. And it's also something that we right now also improving the process, because the application of these bulk trucks and pneumatically send the material, it's never existed before. So these bulk trucks, these barrels, they typically used just to come to the site, dump the entire material at once, and then they leave. But we need to have Mary staying for like, let's say 7 days as you print, and just send the material with portions, right? So yeah, currently we're doing this pneumatically, but let's see, maybe we're going to improve this process and figure out something else. So, but currently, yeah, it's pneumatic, yeah. We installed like additional equipment because like this bulk trucks, they exist without this pneumatic addition. So that was also like how we hacked a lot of different solutions to make it happen. But yeah, thank you for the question. And if you need any help on your other project, happy to talk to you and provide some advice and learning curves. We learned quite much so far to make this work.
Imagine.
Yeah. And just to make sure we're on time, construction waste, additive manufacturing, like a 3D printing, by default, it's a waste-free technology, because this is the opposite fabricating process to subtractive fabrication process. Subtractive, it's when you have the material, let's say like a big rod of the metal, and then you start cut out all of the material to create the shape that you need. And then you have a lot of leftovers of this material that you removed to get the shape you need. With the 3D printing, you do the opposite. You just 3D print the shape as you need, and you add material whenever you need to create the shape. So yeah, for the walls, we don't have the leftovers. We don't cut out the, something we don't need, for example. And in addition to that, because we bring the material for walls just in the barrel, we also don't have all of this packaging, because to build a house like this, it will take like, maybe like 45 pallets of concrete blocks. And all of these pallets, they wrapped with the plastic, and they also stripped with the plastic, fixtures and everything like that. And it's all of the crazy packaging that I really hate. It's like a polluting everything. So we don't have this as well. Lastly, the houses are more resilient to all of the natural disasters. For example, flood and fires, material is more fire resistant. And because we also can 3D print the curved shapes like this, that's going to be, it's actually way more resilient to the wind load and flood load. Because like when you print the straight wall and you apply a lot of pressure, it's not that strong. But if you have a little bit of a curve, then the load distribution is completely different. And this is how the curved structure is stronger for the wind resistant and for the flood resistant. So there are so many ways how you can introduce it to build really just better houses and make the people happy, and the home ownership will become also more affordable because the insurance is better, like a lower cost, because the house is more resilient, and you really need to rebuild your house every other flood or hurricane and everything like that. So that's also the end game, how to make end users happy and spend less time on home ownership, including the utility bills of heating or cooling. Yeah. So I think
what about earthquakes?
Earthquakes. Oh, great question. So the way how you do the houses more resilient to earthquakes, it's basically to add more rebar, make the walls more reinforced. And this is why also in California, you would see more like wood structures are like the most applicable structures here. Of course, first, because when the earthquake happens, the house is just easily, kind of like a fall down. But you still can build the houses out of concrete, even for California, that can be very, very earthquake resistant. It's just more expensive because you need to install more rebar, you need to make houses more stronger, materials are more expensive, labor is more expensive. But with our technology now, we can introduce concrete houses, very strongly built, but still you don't spend more time and money on the labor because it's going to be a Frank working hard.
Yeah. Nice. Okay, so we have time for a couple of more questions. Let me try to cover as much as we can, unless you have anything else that you want to cover.
Maybe quickly, because I think that's important, how we actually print structures higher than one floor. So this is the building in Dubai that we were printing. The full height is 32 feet, which is about 15 meters. But here you see that we basically put Frank on the second floor, and we kept printing the walls of a second floor. So this is how we can do up to 3 floors. Up to 3 floors, basically, because it's a limitations with the building codes. But we can also figure out how to build tall rising houses and buildings. It's just different type of the calculations and how we reinforce the walls. And here you see that actually each floor in Dubai building, it was 5 meters, 4.5 meters tall. Printer could print only 3 meters tall. So to achieve like the full height per floor, we fabricated very simple metal frame, and we put the Frank on it, and this is how we can stand the print height. And that actually, really lastly, that also opens a lot of market opportunities and applications just beyond the single family housing, because we can print higher walls and we are not limited in like how big the structure can be, like a square footage wise. We can 3D print the sea walls, and sea walls is also very important right now because with the rising of a sea level, a lot of cities right now, it's really kind of like a sinking. And New York and other coastal cities, they spend like a lot of money, like hundreds of $1 billion just to reinforce the coastal area. And again, it's a very cost and labor intensive process. We can 3D print it. We can deploy like hundreds of printers of the coastal area and 3D print it, quickly. And also all of the different shapes of the sea walls will help marine creatures to actually live on this sea walls and create bio environment better. And of course, it's like all of the infrastructure projects like noise barrier walls, tilt walls, we can fabricate them quickly on site. So yeah, I just wanted to give the perspective that this technology is not just for the single family houses. Our technology specifically has a very broad application, as long as it's like you have enough land to 3D print structures. That's the only limitation for us, the land.
Nice. So we have maybe time for 2 quick questions. First, where does the name upskillng came from? What does it mean?
Yeah, great question. So Apis, it's a bee from Latin. And bees, they're the first ever on Earth who started using 3D printing to create their homes. As you know, they somehow like extrude the wax and they create the honeycombs. So yeah, we just inspired by nature, by bees. And core, it also means heart, but we basically like just wanted to add something to sound more complete. But apis, yeah, that's the core meaning of that, the bees.
Yeah. And last question, I'm sure you can talk about it for ages. We have maybe 2 minutes left. Tell us a little bit about how easy it is to do wiring, plumbing, and all the things that usually go into the wall when you build a house.
Yeah, great question. So there are two ways how you can do this. Currently, we just install a plastic pipe into one of the cavities in the walls, and then the electrician would come and sneak the wire into this pipe. And then you also cut the hole in the wall where you want to have the electrical outlet, and this is how you connect it. So all of your electrical stuff can be inside the wall. Plumbing depends where it is. Install it on the wall, on the 3D printed wall as a conduit, for example. But sometimes we prefer to do the framed walls in the bathroom area, for example, because framed walls, it's still like easier to get inside and install everything. It's like, if it's like a lot of plumbing, we would recommend to do the wood framed wall, but typically it's like very short, just in the bathroom. And also you can do the traditional conduit, when you just install all of the wiring and plumbing on the wall. That's also possible. So whenever is already existing in the traditional construction, we do the same. Yep.
Gotcha. Okay, Anna, I think we could have gone at least half an hour more with all the questions that we got. I hope I was able to answer most of them, and I apologize for those that we weren't able to address. So first, thank you very much for joining. It was really fascinating. And second, we wish you all the best in the world, because you're doing amazing things. Not only commercially, but also for the environment and for the people. So good luck.
Yeah, thank you so much. Thank you for having me today, and that was a pleasure. Thank you.
Thank you very much. Bye bye.